the net force. Now let's look at the net force itself. So we're going to look at the left side of Newton's second law, the sigma F. The Greek letter, that funny E-looking type of letter, sigma, means sum of. And sometimes sigma F is written as F net, just to say that it's the net force. They mean the same thing. It means that you have to add up all the forces acting on the object. Another thing about net force is that it's a vector. We put the arrow above the F to remind us of that, just as we would over the A for acceleration or V for velocity. We won't always write the arrow up there, but it's very important to remember that it's there. It means that when you add forces, you have to add them like vectors. They have a direction. They can add up in one direction, or they can cancel each other out. I can push a box one way, you can push it the other, and the net force is much less than either of the amounts of force we're applying. So let's do an example and try to understand how to calculate net force. So in this example, we have a 5 kilogram object acted upon by two forces. One, which is 20 newtons, which is acting to the right, and another one, which is 30 newtons, acting also to the right. And the question asks us what the net force on the object will be. Before we get started with this, there's one thing I want to bring up. What you should be seeing here is that we're identifying these forces as F1, the first one, and F2 as the second. So these little numbers down here, what do they mean? Well, they're subscripts. They're just our little way of distinguishing one thing from another. They're both forces, but it's just like a little note that we're writing in small letters at the bottom of whatever we're looking at, just so that we can keep track of what's associated with object number one or object number two. It could be a dog and a cat or a horse and a cart. And we might write those in instead of 1 and 2. So just so that you know what they are, they're nothing special other than a little note. So let's go on with the problem. The first thing we need to do is draw a picture. What exactly is going on? We're going to do something using a thing called a free body diagram. We're going to introduce those or go into those in more detail later. But right now, we're just going to draw a dot to represent the object. That's the beginning of the free body diagram. And then we're going to draw arrows to represent each of the forces. What's important is that the direction of the arrows will represent the direction of the forces. And the lengths of the arrows will give us some idea of the relative size of those forces. All right? All right, so let's move on. Continuing with our example, our object, our 5 kilogram object, we've decided to represent as this little dot. That's our free body, if you like. Now, the first force that we've got is a 20 Newton force, and we said that it was moving to the right. So here's the arrow for F1, which is 20 newtons in magnitude, and it's pointing to the right. Next, we'll want to also show the second force, our 30 Newton force, which is F2, which is also pointing to the right. And here we see it, the second force. So we've got the two forces now, F1 pointing to the right and F2 also pointing to the right. Notice that F2 is a bit larger. It should be around 50% larger, but the main idea is just to show that it is bigger. And so now we see these two vectors pointing in the same direction and of slightly different lengths to represent their different magnitudes. Now, we have the two vectors, F1 and F2. They're both pointing in the same direction. But to add them, you may recall that the straightforward way is to line them up so that one begins where the other leaves off. That's what we call head to tail. So what we've done here is we've taken F2 and we've stuck it on the end of F1, and now the entire length of these two vectors, these two forces, F1 and F2, shows us the sum, and now we can use that to calculate our length. Once we've put F1 and F2 head to tail, we can add them together. The total length of the two vectors combined is now the net force vector. Force 1 plus force 2 is the net force. Now that we've got that, we can look at it from an algebraic perspective. So to do our addition of force 1 and force 2, we're going to define right as positive. So if we do that, we can interpret our diagram. So the net force is the sum of the two, i.e. force 1 plus force 2. Both of them are positive, both of them are pointing to the right, and they are 20 newtons and 30 newtons respectively. So when we add them, we'll get 50 newtons, and it's pointing to the right.